So please observe, if table tab 1 is there, dropping, then tab 1 is creating table tab 1. Then I'm creating one sequence which is starting with 1 every time incrementing by 1. Now, while inserting record into tab 1, you don't require to provide 1, 2, 3, 4, 5. Sequence will be providing from 1 onwards. For first record, it provides 1. For second record, it provides 2. Third record, it provides 3. After inserting maybe 1000 records, you may not be remembering what could be ID for the next record. Leave to the sequence. Sequence will provide what could be the next value. Sequence will provide what could be the next value. So please observe, I'll insert the data like this. Whenever you have a auto incremented value, use the sequence. If any column is there, auto incremented value, incremented sequential value. I'm running all these commands. Automatically sequence provided next value. So we didn't provide 1, 2, 3, 4, 5. We created a sequence which is starting from 1, every time incrementing with 1. Please observe. While creating a sequence, you can specify from where it has to start and how many units it should increment every time. I can go for start with 100, incrementing by 10 every time. Start with 1000, incrementing by 3 every time. It is up to you from where it has to start, how many quantities of the values should increment. Sequence is very much recommended in order to provide a value to the column which is a sequentially incremented. Inside a sequence, you need to call just next val. For tab 1, ID value, it is not a 1 from my side. It is not a 2 from my side. It is not a 3 from my side. I'm just asking the sequence to get the next value. Starting from 1, keep providing 1, 2, 3, 4, 5. We are not hard coding the value. So we don't require to remember what could be the next value for the coming record. For the next record, what could be the value? We don't require to remember. This is about sequence. See, tables are there. Similarly, you can find sequences also. On the left side, you can find sequences. Expand the sequence. Check it out. Tab 1 underscore SEQ. And select the SQL for the sequence. Create a sequence. Minimum value 1, maximum value this much. Incrementing by 1. Start with 21, something like a cache and all. So providing some additional information. So for us, what is the minimum value and maximum value? Starting with sequence. Some interviewers are asking, what are the database objects? What are the database objects? So please observe, database objects, table, sequence. Third one, view. Fourth one, index. Still there are a lot more, but we don't require to bother about others. Database objects. Table is a database object. Sequence is a database object. View is a database object. Index is a database object. Table, sequence, view, index. So we know very well about table. We know sequence also now. Let's see what is the view, what is the index. In addition to this, lot more are there, but mainly we are focusing on all these. Let us see what is a view, everybody. Create view, view name, tab1 underscore v1, any name, as create view, view name as select star from tab 1 where id is equal to greater than or equal to 5. View is developing for select command. View is developing for select command. On top of the select command, we can create a view. In the select command, you can keep a some where condition. On top of the select command, we are creating a view. So please take these two lines, everybody. View created. Create view, tab 1 underscore v1. What we are doing is, for one select command, we created a view. Now let us read the data through view. Come on. Let me go for select star from view. Internally, it triggers the select command. Whatever command we provided to the view, whatever command we have provided to the view, let's go for select star. For one table, you can create any number of views based on your select command. On top of the select command, you are creating a view. What is the need of view? Everybody. Instead of giving a table name to the client, you can give a view name to the client. Customer will not be knowing from which table data he is reading. Customer is thinking like this itself a table. For highest security purpose, you can create a view for your select command. In the select command, there is a table name, but this select command we provided inside a view. Select command we have provided inside a view. This complete select command we have provided inside a view. Now, the view name is this. View name is this. View name is this. So you can go for select a command on view name. Select a command on view name. Select star from view name, name of the view. It is for mainly achieving the security. We are not exposing table name. Second one. The view is based on one condition. While going for select star from view, inside a view, select command is triggering based on the condition. This condition not knowing to the customer. Come on, guys. This condition not knowing to the person, whoever triggering select command. You are just giving one view name for one condition. One view name for one condition. Any number of views can be any number of views can be created for the same table. For one table, any number of views. Let me go for one more view. You can go for any select command inside a view. Any select command. Select a name from tab 1 where ID less than or equal. So let's give a new view name. I'm just choosing tab 1 underscore v2, but you can go for any name to the view. Any name to the view. Come on, guys. This two. For the same table, any number of views can be created. Let me run the, let us create second view. Let us read the data from the second view. Now, the person, whoever using view, he doesn't know what is the select command incorporated inside a view. You can go for reading all the columns or few columns. You can go for reading all the rows and few rows. In order to achieve highest security, views are highly recommended. The client will not be coming to know from which table and what is the condition he is applying to read the data. So client is coming to know. Client is thinking like this is the table. But it is not a table. It is a view on a particular selected command. So he is not knowing what is the selected command incorporated. Views are very, very important to achieve the security. In order to achieve the security, views are very, very important. On the same table, you can create any number of views purely based on the requirement. Inside a view, only one selected command, not multiple selected commands. Only one selected command inside a view. For one selected command, one view. For one selected command, one view. Inside that selected command, you can read one column or multiple columns. You can read few rows or multiple rows. You can read one row or multiple rows. Go for any kind of where condition. So view is a wrapper on select command. View is a wrapper on select command. Please observe. On any of the select command, you can create a view. Based on any condition, you can read one column or multiple columns. You can read one row or multiple rows. Any. So finally, trigger data from the view. Trigger data from the view. Inside a view, whatever select command is there, that select command will be inserted. Sorry, that select command will be triggered. Sequence and view both are very simple. Both are very. Sequence is used for generating sequential incrementing number. View is used for creating one database object for select command result. Inside a view, you can incorporate one select command. For the same table, any number of views can be created. Let's move to the index. Everybody knows about index in the book. Every book having index. In the beginning of the book, you can see the index. Through index, we can come to know. Through index, we can come to know in which page a particular topic is starting. Page number of the topic. Come on, guys. In any book, there is an index. Through index, we can come to know in which page a particular topic is starting. A particular topic is available. Inside a book, if index is not there, searching a topic, it takes more time. Inside a book, if index is not there, searching for a particular topic, it takes more time. It takes more time. Very similarly, in the database also, inside a table, several records are there. Inside a table, several records are there. These records are storing in the hard disk in different blocks. Please observe. Inside a table, whatever records are storing, inside a table, whatever records we are storing, those records are storing in different blocks. Those records are storing in different blocks. Those records are storing in different blocks in the hard disk. Consider block 1, block 2, block 3, block 4. So please observe, inside a book, concepts are there in different pages. Topics are there in different pages. In one page, either one topic or multiple topics. If at all topics are simple, there may be 3-4 topics in the same page. Inside a book, pages are there. In each page, there may be one topic or multiple topics. In the same page, there may be one topic or multiple topics. Same way, whatever records we are inserting in the table, those records are saving in the hard disk in different blocks. Different blocks. In each block, there may be multiple records. In the hard disk, in different blocks, records are storing. So please observe, inside a book, multiple pages are there. Each page containing one or multiple topics. Assume topics are very simple. Multiple topics will be in the same page. Under one page number, multiple topics are there in the index. Similarly, we are inserting some thousands together records in the table. In the table, we are inserting multiple records, multiple records. These records are storing in the hard disk. These records are storing in the hard disk in different blocks. There may be 10 or 15 records in one block. 10 or 15 records in one block. It's purely based on size of the record. In few blocks, maybe very less number of records. Very similar to page in the database. In the hard disk, records are storing in different blocks. That block is having a physical address. Page is having a number in the book. Page is having a number in the book. Similarly, in the hard disk, block is having a address, reference or pointer. Block is having a pointer, reference, address. If 10 records are storing in the block 1, if you know block 1 reference, then you can search any record in these 10 records only, even though table containing thousands together records. I already said, inside a book, if index is not there, searching for a particular topic, very difficult. Inside a book, if index is not there, searching for a particular concept is very difficult. Very difficult. Very, very difficult. I repeat once again. Book required an index to find out where a particular topic is there. Same way, table. Several records are there in the table. Those records are storing in different blocks. If you know the block number, you can easily search for a record. If you don't know the block number, you need to search in all the blocks for a particular record. If you don't know what is the block number, then definitely you need to search in all the records. Assume 1000 records are there. I'm searching for one record. I don't know in which block that record is available. Then I need to search all the blocks in every block of the table. It takes more time. Please observe. Very similar to book, table also required index. This index is record and block number. This particular record stored in this particular block. This particular record stored in this particular block. Whenever I am searching for a record, through the index, I can easily identify in which block that record is saved. Directly I'll go to that block and I'll search the record in that block. I don't require to search in all the blocks. Let us consider 1000 records are there. For these 1000 records, assume 100 blocks are used. Roughly, average 10 records are storing in one block. So 1000 records are there in the table. 100 blocks are used. If at all no index, come on. While searching for one record, this search should be in all 100 blocks. Go to the first block, search for this record. Go to the second block, search for this record. Go to the third block, search for this record. Go to the fourth block, search for this record. Takes more time. This kind of search is called as a linear search. Record by record searching takes more time. In the book also, if index is not there for a particular concept, go to the first page, check whether this concept is there or not, whether this topic is there or not. If not, go to the second page, search for this particular topic. If it is not there, go to the third. If it is not there, go to the fourth. If it is not there, go to the fifth. Linear one by one. Linear one by one. Linear one by one. Linear one by one. One by one. It's not recommended to go for linear search. It takes more time. Definitely, whenever you are searching for a record, you need to identify first block, in which block that record is there. In that block, if 10 records are there, search a record in the 10 records only, not in all 100 blocks. If you are searching in all 100 blocks, it takes more time. So that can be done through index. Inside a table, for primary key and unique, automatically indexes are creating by database manager. Come on, guys. For a primary key, automatically indexes are creating. For unique key also, automatically indexes are created. If you want to search based on non-primary, non-unique column, non-primary, non-unique, non-primary, non-unique, then indexes you have to create. You need to create the indexes. I repeat once again, why do we require an index? Please observe. In one table, there may be thousands together records. Thousands together records. If you want to search any one record, going into every record and comparing, it is a linear search. It takes more time. Assume there are 1,000 records available. I need to search one record. Then, whether that record is the first one or not, second one or not, third one or not, fourth one or not, you need to compare with all 1,000 records. It takes more time. One more point. Whenever record is inserting in the table, database manager internally using blocks of the hard disk to store the records. Database manager internally using blocks of the hard disk to store the data. Let us consider block 1, block 2, block 3, block 4. In block 1, few records are storing. In the block 2, again few records are storing. Block 3, block 4, block 5. Likewise, even though records of one table, those are storing in different blocks. Even though all records are from one table, Even though all the records are from one table, these records are storing in different blocks in the hard disk. Every block is having an address or pointer or reference. Every block having a pointer, reference. Let us consider in the first block 100 records are stored. In the second block again 100 records are stored. In the third block again 100 records are stored. If at all 1,000 records are there, assume 10 blocks are using. Each block is having a capacity of, on average, 100 records. For any record, if you know in which block that record is stored, then you don't require to search for that record in all 10 blocks. straight away in whichever block that record is there. In that block, totally 100 records are there. You need to compare only that 100 records. Generally, block will not be having 100 records capacity. There may be 5, 6 records or 10 records or 20 records capacity for each block. Let us consider there are 1000 records. These 1000 records are stored in 100 blocks. In each block, on average, 10 records. On average, 10 records. Now, if you know the block reference for a particular record, while searching for that record, no need of going into all 100 blocks. Directly go to the block where that record is saved. In that block, if 10 records are there, you need to compare with the 10 records only. You don't require to compare linearly 1000 records. That is why indexes are very, very important for the fast search, very quick search. If you are looking for a quick search, go for indexes. While creating a table, database manager creating indexes for primary key and unique key automatically. You don't require to create an index for primary key column. Unique key column. Automatically, database manager itself creating indexes for primary and unique. Let us consider inside your table, there is a non-primary, non-unique column. There is a column like a first name column. It's not a primary and it is not a unique also. Multiple people will have a same first name. Come on. Multiple people will have a same first name. It should not be primary. It should not be unique. It should not be primary. It should not be unique. In that scenario, no index for the first name. You need to create the index explicitly in order to identify block number based on the first name. If you are looking for a select command based on the first name, create the index. Create the index. Create the index. Create the index. Everybody. Create the index on first name. Then, for every first name, it will be updating in the index. This particular record with this first name, storing in this block. Inside a book, index is concept name, topic name and page number. Inside the index, column value and the second one is block number. Column value, block number. Column value, block number. For a first name, let us consider we are creating an index. For a first name, we are creating an index. For the first name, we are creating an index. Come on, guys. For the first name, we are creating an index. While creating an index for the first name, everybody. Whenever you are inserting a record, it is identifying in which block this record is storing in the hard disk. Take that block, binder, reference, address, and this first name, keeping inside the index. First name ABC, block number. First name XYZ, block number. First name Vijay, block number. First name Mohan, block number. Generally, in the book also, index containing topic name, page number, topic name, page number, topic name, page number. Index is creating for the topics. Similarly, in the table, we are creating explicitly index on top of first name. Whenever we are inserting a record, Assume record is ABC, block number 1. Assume ABC record with first name storing inside a block 1. Then in the index, ABC block 1. ABC is the first name, block 1 is a reference block. In which block? Maybe address, maybe a reference, maybe a pointer storing in the index. Whenever I am looking for first name record, first it will be going to the index. It will check in which block index is available. Block 1. Sorry, in which block ABC is available. Block 1. It will go to the block 1, search for ABC in the block 1 only, not in all the blocks of hard disk. Understanding or not? Indexes are very important. Researcher. You need to create the indexes explicitly on only non-primary, non-unique. Non-primary, non-unique. You don't require to create the index on primary key column. Why? Because automatically index is creating by database manager on primary key column and unique columns. You need to create the index only on non-primary and non-unique. So let us consider here name column. I need to create one index on name column. While creating an index on name column, assumption. Create index on this is the syntax to create a index. On which table and what is the column? On name column of tab 1. On name column of tab 1. Name column of tab 1. I'm creating an index. Come on, guys. Index created. On name column. Now, whenever I'm inserting ABC, internally, for ABC, assume like a name column ABC. Internally, it is identifying what is the block number allocated to ABC. In which block ABC is storing. In which block ABC is storing. Whatever block number is there, block pointer, reference, address, that address is taking and keeping inside an index for a particular ABC. ABC, this is the address. Whenever I am searching for ABC, first it will go to the index. For this particular ABC, what is the block number? It will take the block number, directly it will go to that block number to search for ABC. For quick, very fast retrieval, indexes are required. Very fast retrieval, indexes are required. Very fast retrieval, indexes are required. Now we don't require to use index anyway. Automatically database manager will be keep using index while inserting and even while reading. Whenever you insert any record, whatever name you are choosing, for that name, index is creating. Let me insert to one record. I inserted one record. So please observe. Internally, it is updating in the index Mahesh and this block number. Come on, guys. Already we created one index. Let us see whether we can able to see anything in the index. Come on, guys. You can see here earlier for primary key, unique key indexes are there. We created one index. One index. Come on, guys. We created one index on name column, one index on name column. On name column index is there, but there is no data. Internally it is managing. It's not showing how block numbers or references it is maintaining. Just observe, we inserted Mahesh record. There is an index on top of name. It will be taking Mahesh and in which block. This data will be updating in the index. Come on. We are not able to see what is the content in the index. There is no way to read the content from the index. You need to observe. You need to understand, like Mahesh is storing in one block. Mom, Mahesh is storing in one block. Mahesh is storing in one block. In the index, there will be one update. Mahesh is stored in this particular block. Whenever I am searching for Mahesh, it will not be comparing in all the records. It will directly go to the index. It will try to identify what is the block number. Then it will go to the block where Mahesh is available. Where Mahesh is available. This is very, very important. So please observe. Through indexes, we can retrieve very fast. Through indexes, we can retrieve very fast. Very, very fast. Fast retrieval using indexes. Fast retrieval using indexes. So please observe, we are just creating the index. Based on our advice, database manager will maintain the index. We created index on top of name column. Whenever you are inserting a record for a particular name, it will be specifying block number for that name. It will be specifying block number for that particular name in the index. Whenever you are searching for that particular name, what is the block number? For that block. Very fast retrieval. We are not using index, we are just creating. Database manager will be keep using index. Whenever you are inserting record, it is updating in the index. Whenever you are reading, it is going to the index to identify in which block this data is there. In which block this data is there. Read the data. Understood? For primary key column, you don't require to provide the index. For unique key column, you don't require to provide the index. For non-primary, non-unique columns only, you need to provide the index. Whenever you create an index, then database manager, for every record insertion, it will update in the index. This particular record, this is the block number. This particular record, this is the block number. In addition to these four, still lot more database objects are there, like a stored procedure, function, procedure, lot more. But you don't require to bother. Those are completely database administrators. Even view and index also, mainly database administrators. We will not be bothered. We will be creating tables and sequences. But recently, in some of the interviews, July batch and August batch people, they got questions from view and index also. That is why I incorporated view and index. Earlier, I was not teaching view and index. It was completely database administrators. Recently, interviewers started asking view and index. At the sequence, every developer also should know view and index only for the admins, but recently asking, that is why we should know what is view, why do we require, what is index, why do we require. View is mainly for achieving the security. Instead of exposing a table or a condition, for one condition, select a condition, we are just providing a view. Inside a view, we are keeping a select condition. We require index. Indexes are for fast retrieval, very fast retrieval. So providing index for a particular column value. In the database, there are some normal forms available. The database, there are some normal forms. By using these normal forms, we can design database very effectively. Most of the interviewers are asking normal forms also. Normal forms are nothing but some kind of conditions to be followed, instructions to be followed in order to design a database very effectively to avoid data redundancy. Designing data very properly, designing database very properly. There are several normal forms available. Among all, first three normal forms are very important. We'll go through first three normal forms. First normal form, also called as 1NF. First normal form, also called as 1NF. First normal form, also called as 1NF. What first normal form says is, in one column, inserting more than one value, not recommended. In the first normal form, in one column, insert only one value, not multiple values by using comma as a separator. Not multiple values by using comma as a separator. Insertion. In one column, not more than one value. If at all you are inserting multiple values, search is very difficult. If I want to search for C++, in all the columns I had to look for whether C++ is there or not. In a single column, don't go for multiple values. First normal form says like in one column, insert only one value. In one column, we insert only one value. In one column, one value. Not more than one value. In the same column, not more than one value. In the same column, not more than one value. In the same column, not more than one value. If multiple values are there in the same column, then you are violating first normal form. You are violating first normal form. First normal form says like, don't go for multiple values in the same column. Don't go for more than one value. More than one value. The same column. So if you have this type of table, so try developing in another way. Only employees in one table, all skills in another table. Come on. So if at all data is there like this, employee table, 4 columns. Skills is a column in the employee table. Skills is a column in the employee table. Multiple skills may be knowing, like a Mohan, 3 skills. Ramu, Manu and Pavan having 2 skills. This can be addressed by choosing 2 different tables. Everybody, we are achieving first normal form. Employee table and employee skill table. This is how we can address the limitation. First normal form can be implemented by choosing 2 tables. If at all any column is getting multiple values, split into 2 tables. Don't provide multiple values in any of the column. Don't provide multiple values in any of the column. Don't provide multiple values in any of the column. This is about first normal form. Come to the second normal form. Second normal form, it should follow first normal form and one condition. Observe this point. Second normal form is a combination of first normal form plus one condition. Everybody, second normal form. Second normal form, it is a combination of first normal form and one condition. First normal form and one condition. Without first normal form, you should not move to the second normal form. Second normal form is a combination of first normal form and one condition. First, you need to check whether first normal form is following or not. Then only you have to look for second normal form. Second normal form, it is a combination of first normal form and with one condition. Now you can see here, everybody, second normal form. Second normal form. So trainer, name, age and subject. Come on. Name, age and subject. So here, you have a name, age and subject. Generally, every column should have a 100% functional dependency. Come on, guys. Every column should have a 100% functional dependency. Every column should have a 100% functional dependency, not the partial dependency. Whenever you are talking about a trainer, You will be talking about what is the name and which subject. Come on. 100% functional dependency for any column. Column should have a 100% functional dependency. Functional dependency. What second normal form says is, first normal form plus every column should have a 100% functional dependency, not the partial dependency. 100% functional dependency. 100% functional dependency. Whenever you are talking about a trainer, you will be talking about name and the subject, name and the subject, name and the subject. You will not be bothering about the age. So trainer, 100% functional dependency is a name and the subject, not the age. Age column not recommended in this particular table. Age column not recommended in this particular table. Yes, age also belonging to the trainer, not a 100% functional dependency. Every column should have a 100% functional dependency based on the table. So table, I am trying to maintain trainers. Reception. Trainer name, and subject, absolutely possible. It is not recommended age. Whenever you are talking about trainer and subject, whenever you are talking about trainer and subject, come on. Whenever you are talking about trainer and subject, name is not essential. 100% functional dependency should be for every column, not the partial dependency. Second normal form is like first normal form plus 100% functional dependency. 100% functional dependency, fully functional dependency, not the partial functional dependency. Not the partial functional dependency, 100% functional dependency. So here, if at all Manu is taking two subjects, then Manu's age is repeating 2 times. Ramu is taking 2 subjects. Ramu's age is Ramu's age is repeating 2 times. So remember, full functional dependency for every column, not partial dependency. Full functional dependency for any column should have a 100% functional dependency. So in this table, while talking about name and subject, what is the need of age? Yes, every trainer having a age also, but age is not a 100% functional while talking about subjects and a trainer. While talking about subjects and a trainer, age is not a 100% functional. It is a partial. Every trainer having a age, it's recommended to take care of age also, but not in this table. This table mainly mapping name of the trainer with the name of the subject. While considering name of the trainer with the name of the subject, main functionality is name of the trainer with the name of the subject. In this scenario, age comes under partial dependency. Age is not essential here. Age is a partial dependency. This should be avoided. If you are not avoiding, age is repeating. Yes or no? So here, second normal form is not following. So how to achieve second normal form? Again, go for 2 tables. Almost all the normal forms can be achieved by splitting into multiple tables. Every normal form. So what we are doing here, we are mentioning trainer and subject. Trainer, one table, and the subject is another table. Now, this table, 100% functionality is trainer information. We are not talking about the subject. Now you can go for trainer age, trainer email ID, trainer date of birth. All this comes under 100% functional dependency to this table. We are not talking about the subjects. Now trainer essential information you can provide. 100% functional dependency. You can also provide email of the trainer. Email of the trainer. You can also provide education of the trainer. You can also provide address of the trainer. Then you can go for trainer and subject. Here main functionality is specifying subjects of a particular trainer. Main functionality. Now here subject is a 100% functional dependency. Please check it out. Second normal form. Age is belonging to the trainer, but in the same table you also mentioned subjects. While talking about the trainer name and subject, age is not a 100% functional dependency. It comes under partial. Avoid this type of mapping. In every table, columns should be 100% functional dependency. So trainer table containing trainer essential information and trainer underscore subject table having a more information about subjects and trainer mapping. This is about second normal form. Let's move to the third normal form, everybody. The third normal form is nothing but second normal form plus one condition. Come on. Third normal form is nothing but second normal form plus one condition. It should follow second normal form. It should follow second normal form plus one condition. Plus one condition. Second normal form plus one condition. Second normal form plus one condition. Second normal form plus one condition. What is that condition? Any non-primary column should not depend on other non-primary key column. Any one non-primary key column should not depend on another non-primary key column. Almost every column should depend on primary key column. One non-primary key column depending on another non-primary key column, then violating third normal form. Any one non-primary key column depending on another non-primary key column. One non-primary key column depending on another non-primary key column. Any non-primary key column depending on another non-primary key column, then it violates third normal form. The third normal form is second normal form plus one condition. 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 What is that condition? The condition is any non-primary key column should not depend on another non-primary key column. Come on. Any one non-primary key column should not depend on another non-primary key column. One non-primary key column depending on another non-primary key column, it violates. It violates. In this table, you can see customer ID, customer name, date of birth, street, city, state, zip and email ID. So please observe here, customer ID, customer name, date of birth, street, city, state, zip, email ID. So here, let me give this email ID over here. Now you can see customer name depending on customer ID, date of birth depending on customer ID, email ID depending on customer ID. While considering street, state, city, state depending on zip. Come on, guys. Street, city, and state depending on zip code. Please observe like a address ID, like a zip. Please observe customer name depending on customer ID, date of birth, email ID, all these non-primary key columns, all these non-primary key columns depending on the primary key. All these non-primary key columns, all these non-primary key columns depending on primary. Whereas street, it's a non-primary key column depending on another non-primary key column. City, it is also non-primary key column depending on another non-primary key column. State, depending on another non-primary key column. These four are absolutely correct in this table. In this table, customer name is depending on customer ID, date of birth is depending on customer ID, email ID depending on customer ID. Customer name, date of birth, email ID depending on customer ID. Customer ID. Customer name, date of birth, email ID depending on customer ID. While considering street, city, state depends on zip. It is a kind of address ID. Street, city, state depending on another column which is a non-primary key column. Street is a non-primary key column. Zip also non-primary key column. Street is depending on zip. City is a non-primary key column. Zip also non-primary key column. City is depending on zip. State is a non-primary key column. Zip also non-primary key column. State is depending on zip. One non-primary key column should not depend on another non-primary key column. This is called as a transient dependency. Please observe. Third normal form says like avoid transient dependency. What is meant by transient dependency? One non-primary key column depending on another non-primary key column. Third normal form requests. Third normal form says like avoid transient dependency. Avoid transient dependency. So please observe. First normal form says like don't insert multiple values in one column. Don't insert multiple values in one column. Second normal form says like avoid partial dependency, partial functional dependency. Avoid partial functional dependency. Third normal form says like avoid transient dependency. What is a transient dependency? In any of the table, in any of the table, one non-primary key column should not depend on another non-primary key column. One non-primary key column should not depend on another non-primary key column. If one non-primary key column depending on another non-primary key column, then violating third normal form. It is called as a transient dependency. You need to address the same. So for that purpose, what I'm trying to do, address table. I'm choosing a chip as a primary key. Like a address ID, come on, address ID. I'm just mentioning chip. In the US, every address will have a unique ID that is a zip code. That is why zip code. Every address having a zip. So please observe, it is a primary key over here. Street is depending on primary key zip code. City depending on primary key zip code. State depending on primary key zip code. Customer name depending on primary key customer ID. Date of birth depending on customer ID, which is a primary key. Let us mention this also a primary key. Date of birth is depending on customer ID. Email ID also depending on customer ID. Finally, I'm mentioning a new column zip with a foreign key. Please observe. It is not for data purpose, it is only for mapping purpose. Declare this as a primary key. Now, customer name is depending on customer ID, which is a primary key. Date of birth is depending on customer ID, which is a primary key. Email ID depending on customer ID, which is a primary key. Street is depending on zip, which is also a primary key. Street depending on zip, which is a primary key. City depending on zip, which is a primary key. State depending on primary key, which is a zip. Now both the tables are following all three normal forms. No column is containing multiple values. No column is having multiple values. First normal form. No column is having multiple values. Following first normal form. Then every column is having a 100% functional dependency. Street is related to address only. City is related to address only. State is related to address only. 100% functional dependency. Customer name related to customer. Date of birth related to customer. Email ID related to customer. ZIP is not for data purpose. It is for foreign key purpose. So second normal form also following. Every column should have a 100% functional dependency. 100% functional dependency. Yes, 100% functional dependency. Then the last one, third normal form. There should be no transient dependency. No transient dependency. Please observe, any non-primary key column should not depend on another non-primary key column. Street is depending on zip only. City is depending on zip only. State is depending on zip. All these columns, all these three columns are on. All these three columns are depending on primary key column. Email ID also depending on customer ID. Date of birth also depending on customer ID. Customer name also depending on customer ID. No transient dependency, no partial functional dependency, no multiple values in a single column. All three normal forms are following. These three normal forms are very important for the interviews. You need to apply these normal forms while designing tables for your project. Whenever you are designing tables for your project, you need to achieve all three normal forms like address and customer. No column can have more than one value. Columns should have a 100% functional dependency. The next one, last one, transient. One non-primary key column should not depend on another non-primary key column. Every non-primary key column should depend on primary key column. Every non-primary key column should depend on primary key column. One non-primary key column should not depend on another non-primary key column. This is all about normal forms. Normal forms. I asked you to install MySQL. How many people installed MySQL? How many people not installed? Please raise your hand. How many people not installed? Good. Everybody installed. See, whatever features we experimented in the Oracle, 95% or 98% is same. SQL. Whatever SQL we have seen, almost 95 to 98% one and the same in the MySQL. There will be small changes. There will be very small changes. Those changes you can automatically come to know while using any of the database. While going to the mid-range companies, MySQL is asking. While going to the bigger companies, Oracle is asking. All bigger companies, especially product-based companies, only Oracle. If you go to the stable mid-range or startup companies, MySQL. But 95%, 98% are same. In fact, MySQL is more simpler than Oracle. MySQL is more simpler than Oracle. In case of MySQL, we can create multiple databases very easily. In the Oracle, creating a database, it's a very lengthy process. And developer not creating a database, only administrator creating a database in the Oracle. But in the MySQL, we also can create a database. It's a single one-line command. We can easily create a database in the MySQL. After creating a database, connect to that database and keep triggering SQL commands. There are mainly two changes. I can say 2-3 changes in case of MySQL. Pagination, removing duplicates, and achieving sequence. These three are changes mainly. That's all are same. In case of Oracle, for pagination, In case of Oracle, for the pagination, we have used row num. What is a pagination? Reading the records page-wise. Reading the records page-wise. In one page, 10 records. Second page, 20 records. Like 11 to 20. Third page, 31 to 21 to 30. You can define how many pages required in each page, how many records are there. In the MySQL, we will not be using row num. There is a limit. Try experimenting the limit after the class. In the MySQL, there is a limit. Limit 2, 7 means from second row onwards is 7 records. Limit 10, 20 means from 10th record onwards 20 records. Limit 5, 7 means from 5th record onwards is 7 records. Limit 50, 5 means from the 50th record onwards 5 records. Limit is there in the MySQL. Similarly, removing the duplicates. There is a self-join. Try understanding some extent on self-join. By using self-join, we can remove the duplicates in the MySQL. Please note down self-join. Try experimenting by yourself. In the MySQL, duplicates can be removed through self-join. Try learning some extent by yourself what is a self-join. If you are not able to understand, I'll explain what is self-join, how we can use duplicates. Removing purpose self-join. How self-join can be used to remove the duplicates. In order to remove the duplicates, we will be using self-join. So please, after the class, try doing some kind of research in the self-join. Same self-join we can use in the Oracle also. But in the Oracle, for removing duplicates, we are using row ID with the group by. In the MySQL, to remove the duplicates, using a self-join. Try understanding what is a self-join. If you find a difficulty, afterwards I cover. The third one is, in the Oracle, we have a sequence to provide a sequential numbers. In the MySQL, there is a keyword called auto_increment. In the MySQL, to provide sequential numbers, there is a keyword called auto_increment. 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 Understood, everyone? So in case of MySQL, there are some simple commands which you should know. Afterwards, you can experiment. Create database, name of the database. This much is simple to create the database. A simple command to create the database in the MySQL. Then, in order to see all the databases, there is a command called show databases. In order to see every available database, show databases. In order to see every database, to connect to one particular database, specify use space with database name. In order to connect to one particular database, in order to connect one particular database, in order to connect to one particular database, in order to connect to particular database, use space database name. Use space database name. Name of the database. Then simple table creation. Before creating a table, you need to connect to one database through use. Come on, guys. Before creating a table, you need to connect to one database through use space, then create a table. Let me go for table name. Let's go for ID. You can mention directly int. It is a just varchar, it's not a varchar 2. It's not a varchar 2. See, several commands I showed you to run in the Oracle. Several commands we have seen to run in the Oracle. So that is why these records, these commands are simple. Let us consider, I need to create a table with a tab to ID int auto increment. Insert into tab 2 name comma age use by providing from comma 4. If we do like this, automatically you'll be getting for Ramu ID as a 1, Mohan ID as a 2, Babu ID as a 3. So automatically incremented value will be getting. You don't require to provide ID value. We already qualified ID as a auto increment. You can experiment all these commands. Finally, show tables in order to see whatever tables available in the current database. So whatever features we have seen in the Oracle, all features you can check it out. If any feature is not working, try understanding what is the change in the syntax. Definitely, you should have a minimum self-learning. Minimum. Here I already said 3 to 4% of commands are changing. That change you can easily understand. You're not a beginner. I made you as an expert in the SQL. I'm thinking like everybody became an expert. I don't know. It is up to you. So in other batches, I was running the predefined commands. But in this batch, every command composed, explained in the detailed way. So definitely, each and every concept you might have went through. Everybody keep practicing, doing complete research. The main research I'm expecting from everybody, self-join. Self-join in both Oracle and MySQL. One, self-join both Oracle and MySQL. Same. Whatever inner join we have seen, same is available in the same way in the MySQL. Whatever outer join available in both Oracle and MySQL. Likewise, self-join available in both. Everybody identify what is a self-join, understand what is a self-join. In the MySQL, To remove the duplicates, self-join is using. In the MySQL, through self-join only, duplicates removing is possible. There is no row ID in the MySQL. Row ID, row num, both are very specific. In the MySQL, remove the duplicates. These two, try experimenting everybody. How to achieve self-join, what it is. Then how to remove duplicates in the MySQL. Simple.